Hi again, I'm Dave Kennett, W8KFJ. This is part 3 of my video, How to Get More Out of Your Elad FDM Duo. If you haven't seen parts 1 and 2, I would suggest watching them first. Part 1 discussed operation of the Duo in standalone mode, and part 2 is about basic software operation. This is a discussion of some advanced features of the SW2 software. I'm recording this in April 2017, and since changes come so fast, it might not be up to date when you see it, and I'm sure I've missed some things as well. Before we get to the nitty-gritty, it may be helpful to understand how Elad handles the files associated with the Duo. As you might expect, the main program files are normally installed on drive C in the Program Files folder, then in the Elad folder. If you're running a 64-bit version of Windows, the Elad folder will be in the Program Files x86 folder. Our main concern, however, is another Elad folder in the Documents folder in this PC. The Elad folder contains an FDM SW2 folder, where you will find many files of interest. These relate primarily to the custom settings you make to SW2, and to related files such as memories, logs, and recordings. Understanding a little about these files will help things go smoother. I'll discuss them as they become relevant from time to time. Since the file name extension is sometimes important to our discussion, open Windows Explorer, then the View menu, and ensure that File Name Extensions is checked. This is how it works in Windows 8.1 and will vary some in different Windows versions. It's important that you see the file name extensions, the part after the period. In particular, files with the extension XML are text files defining your settings. The file name itself can give you a pretty good idea of what's inside. The setup form truly allows you to make this your radio. It's opened with the Set button in the lower left corner of the SW2 window. I will mention some of the highlights under each tab. Detailed information can be found in Section 3 of the SW2 User Manual. Notice that no changes take effect until the Apply or OK button is pressed. Also, you must close the Setup window to return control to the main SW2 window. The first tab, Tuning Step, shows a table occupying the top half of the setup window and a smaller table in the lower left corner called Step Presets. The upper table allows you to define bands by specifying a start and a stop frequency. You can then assign attributes to each band, such as mode and tuning step, and create as many bands as you wish. There are also some related options just below the table. This is a little confusing as they use the word default a little differently. If you check the Use Default Step box, you will use the tuning step you entered in the table. Use Default Mode gives you the option to enable all, disable all, or enable selected bands by checking the appropriate box. To the right of Mode, you can choose to enable or disable the attenuator, as well as the 54 MHz low-pass filter. This is the same low-pass filter that appears in the upper right corner and in Menu 2 in the radio as RXLP. The software and radio controls are locked together and should only be disabled during special operation above 54 MHz. Therefore, all the LP boxes should be checked for normal operation. The next column, Offset dB, will change the calibration of the dBm scale along the left side of the spectrum, as well as the S-meter. The last column, DW Conversion Mode, appears to be for operation above 54 MHz. Don't check any boxes for now. Note that none of the settings you have made here are active unless you check the Use Tuning Frequency Related Settings table box in the upper left-hand corner. The step presets capability is really handy. It means that when you tune, say, to a CW frequency, you'll already have the desired mode, tuning step, and filter. This happens for each virtual receiver. Let's look at a portion of 40 meters showing some CW and some voice frequencies. As each receiver is moved between the voice and CW bands, it will assume the appropriate configuration. You may save and load complete step preset settings into different files. And guess where these files get saved? In the Documents Elad SW2 folder. I mentioned in Part 2 that the tuning step can be adjusted with the keyboard left-right arrows. Well, using the Step Presets box in the lower left corner, you can set the value you prefer for each step when you use the arrows. You can type in different values, or enable and disable any of the steps. Do it your way. Next, we're going to jump to the Advanced tab, just about in the center. This will help us understand some settings we make on other tabs. Right under the row of tabs is a wide drop-down menu called Device Configuration. Click on it, and you'll see a wide selection of data acquisition rates, ranging from 192 kHz to 6144 kHz. This equates to the maximum width of the spectrum waterfall display, although slightly less is actually shown. The last two choices are quite special. They allow two-channel operation. Now, channel 2 is like a whole other radio with its own 4 virtual receivers. Its operation is completely independent of the main SW2 window or channel 1. It can have another spectrum waterfall display on a completely different band. Only 192 kHz or 384 kHz spectrum widths are available, however. Take note, if you choose any spectrum width higher than 192 kHz, the radio cannot operate in the standalone mode. The S meter on the radio disappears and there is no sound from the radio. You can still use the tuning knob, however. After choosing one of the two-channel modes, a CH2 or Channel 2 button will appear between the AF and Zoom buttons in the upper right-hand corner. Press it, and a whole new radio will appear. It works just like Channel 1, and if you haven't already wanted more than one monitor, you will now. I will continue to use the single monitor and show you some tricks to make better use of it. Actually, I'm not even using all the resolution of this monitor. For the video, I'm capturing a resolution of 1280 by 720, which seems to look good on YouTube. Most monitors would show more than that. To save space, you could use the IF view and shrink the main view to the taskbar, or slide a portion of the window off the screen. Get a little creative and decide what you really need to see. I'm going to digress a bit here in order to clarify some issues with front-end receive filters. There are two types used in the Duo. We had mentioned earlier that the 54 MHz LP filter or low-pass filter should always be activated unless you are using the down converter mode to tune above the 6 meter band. This is a so-called anti-aliasing filter and is used to prevent frequencies higher than 54 MHz from being digitized inadvertently and allow incorrect data to be created. This 54 MHz low-pass filter is activated using the checkbox in the upper right-hand corner of the main display or using menu 2 on the radio. Always use this filter unless you're using the special down converter mode to tune above 54 MHz. The other type of filter is called a pre-selector and is used to keep frequencies that are far removed from the frequency we're tuning from entering the A to D converter. Traditional amateur receivers have used a band pass filter for each of the ham bands. It appears that the Duo uses the existing transmit low-pass harmonic filters in the receive mode as well, providing some protection. So why are we talking about all this now? Adding channel 2 creates a special problem. What if we're using the main channel 1 receiver on 40 meters and channel 2 on 20? The 40-meter low-pass filters used by the 40-meter receiver will keep any 20-meter signals from getting to the channel 2 receiver. So what's the solution? Don't use any preselector filters at all. This is accomplished using menu 10, Fill Bypass or Filter Bypass in the radio. Set it to on. This is not the default setting. It's a good thing that in the direct sampling receiver, filters are only required in extreme conditions such as really strong AM broadcast station, or maybe a nearby ham. That's why they're not standard in many direct sampling radios. Check the Elad website where you'll find a variety of filter options, as well as an experimenter board that you can use to devise your own solution. There is also an inline high-pass filter to greatly reduce interference from the AM broadcast band, a common problem. It will handle 10 watts power, so it can be placed in the TR antenna line. Just below the device configuration menu are some checkboxes. Show HW or hardware setup form at startup gives you some alternatives to opening SW2 using the Duo. It's the same form that shows up when you don't have a radio connected. Normally I see no reason to check it. I suggest checking Auto Start Demodulation so it won't be necessary to press the power button each time the software starts. A heads up, some operations like playing back a recording turn the software off, so if the software stops running, check the power button or check that it's activated. Display aliasing frequencies refers to this radio's ability to tune the higher frequencies above 6 meters using some unorthodox techniques. We'll not be discussing that now, just don't check it. I can't find any information concerning the ADC-DC offset correction, so leave the default. Below that are two boxes, down converter mode and to the right, transverter mode. These are two different methods for operating above 6 meters. For now, make sure they're not enabled. The down converter mode uses the aliasing frequencies recently mentioned. Section 3.6 in the SW2 manual discusses this a bit, and the Elad Yahoo group may help. I don't have any experience here, so you're on your own. The wide box below appears to enable a pan adapter to display an IF spectrum from another radio. Don't check it. There are two boxes in the lower right concerning profile settings, and we'll be discussing those later. Okay, now we're going back to the Tuning tab, second from the left. The table occupying the top half of the window allows you to customize those 16 band buttons. They say preset buttons in the manual, in the lower right corner of the main window. That's right, if you don't like the bands they gave you, make your own. In the left column, you can enable or disable each button. The color block allows you to set the color border of the selected button and the color of the related band edge markers in the pan adapter. You may choose from custom, web, or system colors. Start and stop define the frequency range for each band, as in the Tuning Step tab previously discussed. The next four columns can be set differently for Channel 1 and Channel 2, selected by buttons off to the right. LO, or local oscillator, determines the center frequency of the pan adapter, the same as the radio. Tune sets an initial operating frequency. You can set the mode and bandwidth and add text to the button. Click anywhere in a row to select it. Then click in a box to make changes. Also, once a row is selected, you may move it up and down in the list using the Move Up and Move Down buttons, changing its position in the array of buttons as well. Just below the table, I have checked both boxes to return to a band using the last settings and to show the colored band limit markers in the pan adapter. If you go too far astray, there's a button to return to the default settings. Below that are two boxes labeled Band Bar and Middle Bar. These refer to the two high-speed drag bars below the spectrum display. You can set the width of the displayed span for each, thus setting just how high speed it is. Notice you can also set the mouse wheel scroll step. Remember that you can use the mouse scroll wheel to tune the selector receiver while hovering in the pan adapter. And remember further that if you simply hover over either of the two higher speed drag bars, you can tune with a larger tuning step. Well, here's where you set the tuning step for each. Nice. Just below, you can reconfigure the tuning operation of the 4 arrow keys to configuration A or configuration B. It's pretty self-explanatory. Moving on to the Audio tab, at the top you can define the attack and decay time for the fast, medium, and slow AGC settings. In the large Audio Out box, you can configure the audio output in a myriad of ways. Normally, you would leave sound card audio out checked and main output device set to speakers with whatever sound module is in your computer. Alternate choices are Line FDM Duo audio version 1.04 if you have a USB cable connected to TX, and virtual audio cable software if it's installed. I have VB Audio Virtual Audio Cable, the free version, with only one cable available. You might want to use these in some special circumstances, but it's normally set to sound card audio out, so it goes to your speakers. I have the volume gain multiplier set to 2. This establishes the range of audio levels at the output. I have checked mute on TX or cat keyed status and unchecked freeze spectrum on mute or cat keyed status. They just do pretty much what they say. While the previous settings affect the main audio out, the AUX output device or auxiliary output device settings below allow you to choose which of the 8 available virtual receivers is fed to which output device. Notice that you may enable any or all of the 4 virtual receivers in channel 1 and any or all of the 4 virtual receivers in channel 2 and assign them to any of the available output devices. This allows you to configure connections between any of the 8 virtual receivers and digital mode programs such as Digipan, FLDigi, EasyPal, JT65, Whisper, CW Skimmer. That signal could be audio, or 192 kHz spectrum, a 48 kHz spectrum, or wideband FM multiplex. The level of this output is adjusted with the volume 2 slider for each of the 4 receivers. It is very flexible, allowing multiple connections, and it's all done without requiring any additional hardware such as signal link. Remember, this receiver is capable of tuning higher frequencies, including the FM broadcast band, thus the wide band FM option. I will not be discussing it now. At the bottom, you can adjust the sound card play buffer size. A shorter delay causes less delay, but may cause breakup. Depends on your computer. To the right, mute the VRX not selected should not be selected, as I had suggested in Part 2. That's just my preference, though. To the right of the Audio tab is the Graphics tab. Across the top are 3 boxes containing adjustments for the main, IF, and audio spectrum windows. Full BW or bandwidth spectrum in the main window displays the entire sampled spectrum, including the ends where the signal level falls off. The IF spectrum offers no such choice. You can only display the entire spectrum. A little bit of plot averaging smooths out the noise. Too much makes the display slow and syrupy. I like 2 on the main and 1 on the IF. But it's adjustable, so do what you wish. Peak persistence is nice if you like that sort of thing. The General Settings box in the lower left corner is somewhat self-explanatory. The waterfall update time can be slowed down. I like the 2S or 2-second choice, which slows it down quite a bit. The longer times really slow it down. In spite of being in the general section, this only affects the main waterfall. I can have a slow waterfall in the main window and fast in the IF, no choice there. The window setting, way at the bottom, chooses the mathematical algorithm used to calculate the FFT spectrum display. The choices are named after the people who developed them. The changes can most easily be seen when zoomed in. You can play with it, but we'll probably just leave it at the default Blackman-Harris. In the lower right corner is a big button labeled Edit Color Settings. It opens a big and colorful color settings window. I never did like the dark red Receiver 1, since it's the one I see all the time. I changed it to yellow. I then made Receiver 2 red. I put them back for this presentation, though, so as not to confuse you. I also changed some of the gray text to white and make it a little easier to read. The rainbow at the bottom can be used to add colors to the custom settings palette. There are buttons in the lower left corner to restore defaults and to load or save your settings to a file. And where is that file? All together now in the Documents Elad SW2 folder. In the lower right corner, you can apply your settings and close the color setting window. Next is the Demod Settings tab. Remember that the Z and X keys can be used to adjust receive filter width. The reason that's important now is that the block along the left side, BW presets or bandwidth presets, allows us to determine the filter choices we make with Z and X. We can change the values or even omit some settings. Make it your radio. At the top and to the right of the BW presets block, there are a couple of CW settings, but since CW setup has been accomplished in the Duo itself, these settings have minimum significance. If you want to hear the CW side tone, you must listen to the radio and not the software anyway. There is considerably less delay too, and this is more critical with CW. Setting CW pitch the same as the radio ensures that the pitch will be the same listening to the software or the radio or the side tone. Using the main display for rough tuning and finer tuning with the IF spectrum gets you really close. A little fine tuning using the knob with a tuning step of 10 Hz or less gets you right on. For CW, I already have the tuning step at 10 Hz in the software. If you want it finer than that with the knob, be sure to turn snap off in the software. If this is a little confusing, review Part 2. USB Lsb Settings allows you to set the default lower audio frequency limit for the receive filters in the SSB position. Of course, you can still grab either edge of the filter to adjust it in the IF spectrum view. There are settings for RTTY BFO, FM, and wideband FM. Remember, it's possible to tune VHF with the Duo, although it's a little tricky. The broadcast or wideband FM de-emphasis in the USA is 75 microseconds. That's just for you folks who want to experiment with the down converter mode. Next is the Remote Control tab. In the upper left-hand corner, you can set up CAT commands independently for each of the 8 receivers, 4 for channel 1 and 4 for channel 2. In our use here, a CAT command is not something you teach your cat to do. It is an abbreviation for the Unix and Linux concatenate command, meaning to link things together. Here, they are used to link programs together. Once you set up multiple receivers to feed various digital programs in the Audio tab, you can now direct CAT commands from the various programs to the appropriate receiver. Below that are settings for a web server, just one more of the many Duo options. To the right, you can enable OmniRig, free software to synchronize the Duo with another rig. A friend used it to synchronize his Elad S2 receiver to his Kenwood TS2000 for transmitting. I have not used any of these features. Since we've already talked about the Advanced tab, we'll skip over to the T-Mate2 tab. T-Mate is a knob and button controller made by Elad for a variety of SDRs. It seems redundant to me in the case of the Duo, but remember SW2 is also used by the S1 and S2 receivers. I have no experience with this. The next tab is Station Memory. It allows you to set up and save memories, which can later be recalled with the Mem or Memory button in the lower left corner of the main window. Don't think of it as just memory, though, it's much more. On the left side of the Station Memory window near the top, you'll see a drop-down menu to select Station Memory Source. The top choice is File and refers to the file used to save your memories. Well, it's not just a file. It can be a number of files. These files are kept in the default Station Memory directory just above. Notice that it can be changed, but what is the default location? The Documents, Elad folder, then the FDM SW2 Memories folder. The box in the left center contains a list of memory files. Initially, there is only one, but you can create more. The 4 buttons just below the box allow you to load, unload, edit, and create new files. The large box to the right shows a list of memories contained in the files shown in the box to the left. Only the memories in the files checked as enabled are listed, and these are the only memories listed in the memory window called up by the memory button or the Mem button in the lower left corner. Because the memories can be displayed in the spectrum display, it's possible to add memories primarily to create markers in the spectrum display. For instance, I have created some memories strictly to add frequency markers. You could mark the edge of, say, a general class band or a favorite frequency to easily spot activity on the spectrum display. Click on the color box just to the right of the enabled box, and you can change the color of the markers as well as a block that shows up in the recalled memory list. By putting different kinds of memories in different files and assigning a different color to each, you can find them more easily. For instance, make all PSK31 memories green. That way you can find them easily in the memory list or on the spectrum display. In addition to memory files, the Station Memory Source drop-down menu offers a choice of DX cluster or CW skimmer data or EIBI database, a listing of short, medium, and long-wave stations broadcasting around the world, or SW2. I have only used the regular memory files and the EIBI database, so I can only comment on those. The EIBI database contains information on shortwave and other broadcast stations around the world. I didn't count them, but it's a big list. And a marker is now placed on each of those stations you always wondered about. In the same way, CW skimmer or DX cluster information can be displayed on the pan adapter, and this shows up as well in the memory list when activated by the memory button. I have not used either. Across the bottom are some drop-down menus to define how this information is displayed on the spectrum. They are pretty self-explanatory. Next is the Recording tab, allowing you to define the extensive recording capabilities of the SW2 software. You can record and play back standard audio recordings as well as recordings of an entire spectrum using the Windows standard WAV file format. You can even tune all 4 color frequencies simultaneously in a spectrum recording just as if it were live. Want to see what's happening on 80 meters while you're sleeping? Set the timer to record the whole band and listen the next morning. You can even edit the files to save only a portion you wish to archive. The main recorder controls are in the lower left corner of the main window to the right of the power button. You'll see the common record, play or pause, stop, and loop buttons, and A and B buttons that are used to mark a section to save as a new file. the editing function I just mentioned. The File button just above allows you to open a file for playback or right-click to save a new file defined by the A and B buttons. When recording an audio file as opposed to a spectrum, you also record what you transmit as well as receive. You could edit it with the A and B buttons, then transmit it using an advanced TX feature, which we'll discuss later. The wide box to the right shows recording or playback status, along with filter and DSP settings for the selected red, yellow, green, or blue receiver. To set the recording parameters, select the Recording tab. At the top of the window, you can change the default recording directory, which is Documents, Elad, what else? The second line allows you to set the default file name. You can enter a file name in the normal sense, but intersperse a variety of information about the file, like date, time, frequency, mode, and serial number of the radio. Simply enter the hash mark, or # if you're old school, followed by an uppercase D, F, N, T, or M. Here's my entry into the default file name block, which yields a file name like this. By putting the date variable first, the files are listed chronologically. Below that, you can disable low disk space check, and below that, you can set the maximum file size in megabytes and the maximum file number. If you allow more than one file, the player will string them together as if it were playing one large file. This becomes very significant when you record wide spectrum files. A 6.14 megabyte wide spectrum takes about 2 gigabytes per minute. I set my size to 4,000 megabyte, that is 4 gigabytes. I set the maximum file number to 1, since I didn't want to inadvertently store much more than about 4 gigabytes without giving it some serious thought. You can store over an hour of 192 kilohertz wide spectrum in that 4 gigabyte file though, so it's only a really wide spectrum where that becomes critical. Notice that to the right of the file size and file number boxes are the maximum recording times available at the present spectrum width. The last choice on the Recording tab is the sound card record buffer size in milliseconds. I don't see any mention of this in the Elad manual, but the general rule is that if you get audio stuttering, increase the delay or the buffer size. Notice this affects recording. Back to the main display. By right-clicking on the Record button, that's the circle, you open a window that pretty much duplicates the settings I have just described, except that the maximum time for a particular file size and sound card record buffer size are not shown. In addition, though, it has settings for the recording timer, allowing you to schedule recordings. The settings are pretty self-explanatory. Back to the Setup window. The next tab, Server, has some settings for the server function I have no experience here. The Duo is indeed a very capable piece of equipment. The About tab on the right tells you all about the radio, the firmware, and the software you're using. This same information about the radio and firmware is available at menus 83 and 84 on the Duo. Back to the main window. The User Profile button in the upper right corner, next to the Elad logo, opens the User Profile window. Here you're able to store 8 complete settings for the SW2 software. Set up the software exactly as you would like it, then give it a name and save it to a profile. Recall or load the profile, and everything is exactly as you have left it. And look what I found in the Documents Elad folder. A bunch of folders named after the labels I gave to each profile, and inside, some XML files containing all my unique settings. Everything we have done with the software so far has only required the use of one USB cable to the RX connector on the radio. In Part 2, we briefly mentioned the FDM Duo button in the upper left-hand corner of the SW2 main window. Clicking it opens the FDM Duo standalone control panel, giving us control of the radio itself, even allowing us to alter its standalone characteristics. Did you get that? We're modifying the radio so that later, even when your computer is not around, the standalone Duo will still be your radio. The FDM Duo standalone control requires that another USB cable be connected to the CAT connector. This now allows the exchange of CAT commands, thus linking programs in the Duo together. The top box, labeled Mode, allows you to confirm that RX1 is locked to center frequency and determines the transmit configuration. I just leave them checked. The next box below, Antenna Automation, does the same thing as menu 31, Antennas in the radio. The volume slider below that changes the volume in the radio, the same as E1. You must be listening to the radio, remember, not the software. The volume aux control changes the auxiliary volume, the same as menu 6 in the radio. The TX Power drop-down menu does exactly the same as menu 34, TX Power. Below, we can set the AGC response or turn it off. The AGC gain only works when the AGC is off. It is not the same as AGC threshold. So far, I have not encountered a situation where I wanted the AGC off. Below that is a large block containing 16 macro buttons, which allow you to execute several operations with the press of a single button. But how do we program the buttons? Well, I did some snooping and found that clicking the gear in the lower right-hand corner opened an options box, providing some information on the firmware and what appears to be an automatic frequency alignment tool. But what was most interesting to me was the macro folder. That led me to the FDM Duo macro txt file. Each line starts with a label on a button, followed by a semicolon, then some CAT commands separated by semicolons. Check out the CAT commands listed in the Duo manual and do some experimenting. Click the FDM Duo Manager button at the bottom and you're presented with a window giving you access to some inner workings of the Duo. You must use the hardware COM port defined in Device Manager as determined way back in Part 1 and set the baud rate, which must match the baud rate set in the radio with menu 70 CAT baud. Pressing the Start button will then load a variety of data from the radio into the software. You may then modify the data, then load it back to the radio. Let's look at the left tab, Memories. The main purpose here is to transfer memories you have created in the software to the radio, along with any names you have given them, so they'll be available in the standalone mode. The block on the left contains the memories in the software, which you can then transfer to the block on the right containing the 199 memories available in the radio itself. So the software, or the source block on the left, will be whatever you have set in the Memories tab in Setup. If you have set EIBI database, then that will be your source. So be sure to set your own memory files in the Setup Memory tab before you start, unless of course you want to transfer some memories from the EIBI database. Execute the transfer by highlighting a source row in the left block and a destination row in the right block. Then click on the arrow pointing right at the bottom center of the window. If you have the desired memories transferred, but would like them in different memory locations, you can move a selected row up or down with the buttons on the right, or move a selected row to a particular row with the button below the box. You have an option to save present settings to a file or load from a file. The load button on the top right will reload the settings from the Duo, undoing any changes you have made. The save button on the lower right will save the changes you have made back to the Duo. The next tab, Backlight, allows you to change the color of the backlight on the Duo for 5 different situations. You choose which one by making a choice from the drop-down configuration menu. Adjust the sliders, then click the Set Color button to see how you like it. Look at the display on the radio, remember? Store the selected configuration, then choose another. You may reset any configuration with the default button or reload all the configuration from the radio, undoing all your work. Click Save All Configurations and you're done. The next tab, CW Messages, is pretty straightforward. Type in any of the 10 messages, save it, and then save all. You can then access them in the standalone mode as discussed in Part 1. The rightmost tab, Preselectors, allows you to program the use of either the QSF+6 or the QSF+8 optional preselector. You can define a band of frequencies so the radio will switch to a particular filter position when you're in that band. All the settings made in the FDM Duo Manager must be saved, thus written back to the radio itself. To the left of the FDM Duo Manager button is a Tune button. It initiates the tune mode, just like holding in the mode button on the radio. Back to the main window. The Log button in the lower left corner opens the Logbook window. It appears to be a basic, functional logging feature. When you open the log, there will be nothing in the main data box until you select either UTC or local time in the upper right-hand corner. Your listings will then be displayed with the appropriate time and sorted by the ID number on the left. Pressing the New button opens a window to make a new entry, or log as they call it. You may sort by any column by clicking the column name at the top. Clicking again reverses the sort. A small arrow next to a column name indicates the present sort. You can click on any row to display the full information at the top, but this seems only to work right when the rows are sorted by ID number on the left. Strange. The only way I found to reorder by ID number is to select the alternate time mode, UTC or local, then go back to your preference. I think most everything else is pretty self-explanatory. The Open and Save buttons allow you to have several log files with different names stored where? In the Documents Elad SW2 folder. Remember the TX button just above the waterfall that we talked about in Part 2? There's a button for each active receiver, and we could use it to select which receive frequency we wanted to use for transmit. We could also select mode and switch between microphone and USB transmit inputs. To use the USB input, we must install a USB cable between the TX USB connector and your computer. Let's now talk about the ADV button that opens the Advanced TX window, giving us many more transmit options using the TX USB input. In the top block, we have a drop-down menu for audio in, with choices of the FDM Duo microphone, a VB virtual audio cable I installed, or the line from a Duo. Plug in another source device, such as a USB microphone, and it appears as well. In the bottom block, we can choose the wave out destination. Selecting the computer speakers might allow us to preview the adjustments being made. The VB virtual audio could give us a variety of other options, but we would normally choose the line input to the Duo, thus feeding the transmitter. After making these selections, we can power up the many processing options in this window. Once powered up, we can no longer change the input or output. We'll have to power down to change them. There are 6 more blocks available. We can play files. Up to 4 audio files are immediately available for transmission with the press of a button. We can open a window to choose those files with the Set button. Select an audio file and label the button. Activate a 7-band transmit equalizer, or set up Vox, which can only be used through the Advanced TX panel, not directly through the mic connector on the radio. and a very versatile compressor, allowing a wide variety of adjustments on the transfer curve. A power button must be pressed to activate each of these processors. We can change filter and modulator settings, which operate independently of those in the radio. We can then check various stages of the processing with a waveform monitor. There are tune and Pt3 or push-to-talk buttons at the bottom as well. There's a lot here, and I have not yet fully investigated everything. There's more. Hopefully I've clarified a few things for you, but I fear I've already overstayed my welcome. At this time, I'm not planning any more videos, but we'll see. 7-3.